Hey, good afternoon, everyone. We just about to start, right? We have the full house here. We have Daniel Scott Rainford, we have Daniel Larsen from Microsoft, Craig, Will Valida, and me, Colin, and Alessandro should be joining soon. And we're going to be starting in about a couple of minutes. Just give a little bit more time for people to join. Right now we have 24 attendees and growing. And as usual, if you wanted to say hi or ask any questions or anything, just use the Q&A and we should be able to talk. And how's everyone going while you don't start? You don't need to be quiet just because we're live.
So that's a bit counterproductive, counter to what you said, Wagner. Everything's like,
Yeah,
okay, everyone's like, quiet, we're going live. Now it's like, everyone talk.
Okay, Anonymous is saying hi. Hi, Anonymous.
Oh yeah, keep in mind there's also that couple of seconds delay between what we're seeing and asking everyone to do.
Yes. There we go. Okay, so how about we start? And then people catch up when they arrive?
Sounds good.
Okay, so one more time, good afternoon, everyone. And thanks for joining us for another Auckland Connected System User Group Meetup. It's September already. And today we're going to be talking about Azure Service Bus, high availability and disaster recovery. So it's going to be quite cool. Before we go, a little bit about us. We clock over 500 members now. With organizing Global Integration Bootcamp since their start. Our leadership team grew, right? I started with me, Craig, and Colin. Mike Howell joined, and now we also have Alessandro and recently Will. So we're starting to get more people to help us. But we're always looking for help. So if you wanted to help and continue the user group going and the presentations going on a regular basis, you can either volunteer for a talk, you can suggest some topics and then we try to find any presenters for that, or you can raise your hand to help with organization. I think it's the third time that I say that, but Will did this in the beginning of the year, and now he joined the ranks and is helping us to organize. We have a Twitter account where we always post what is happening with the user group, right? So you see like once in a month kind of activity there that is at ACSUG_NZ. And now, since the pandemic, we also have a YouTube channel. So as anything that is streamed today, go and subscribe to your channel. You can find that on that URL here, right? bit.ly/ACSUG-channel. But let's talk about today's show. What we have today, as I said, is Azure Service Bus, high availability and disaster recovery from the one and only Daniel Larsen. You know Daniel Larsen maybe as technical evangelist from Microsoft and lately as Senior FastTrack Engineer, and where he's working with a lot of companies, bringing the power of Azure to the organizations. And every time that we start a talk, I talk a little bit about something that is like specific to that one. I'm not going to talk again why we have that. You probably can see that from other meetings, but Craig is already laughing.
Yeah.
So it's kind of related to him. But that one, like the legends that I have for today is Dennis joining us after presenting a 2-hour webinar at Microsoft, right? So kudos for him to be a trooper and being now in the second session in a row. And this session has been brewing for a long time. I think first time that Dan suggested that was during Global Integration Bootcamp back in March.
That's right.
And I was quite selfish in saying, no. That one I think is much better for the Connected System User Group. The third legend that I don't have here, but it's quite important, this meetup is probably the second or the third that is done in conjunction with our friends from Azure Lunchtime, which then is one of the organizers, and from Azure Auckland User Group, which then Scott Rayford is one of the organizers. So we have Dan and Dan here as well, helping us to bring more people to that. And we're trying to do that more and more, bringing like those sessions that we think that it goes across the whole user groups and making a shared one. So then if you wanted to share your screen, we can go, and then I'll put you online as well.
Okay. Let's try this. How's that?
That is perfect, and I just need to send you live in 3, 2, you're on.
Okay.
So,
can you hear me okay?
All good.
We can.
Thank you so much, Wagner. Tēnā koutou katoa, ko Daniel Larsen taku ingoa. Welcome everyone to the Auckland Connected Systems User Group, also Azure Lunchtime Meetup and Azure User Groups. A very warm welcome, haere mai, to both the members and the organisers. We always have to say a big shout out to our organisers because they work so hard, and I'm really thrilled to see that we've combined forces. I think it's a really good idea. This is, can you see my camera? You probably can't, but I'm standing in the MPC where we have had so many meetups and it's completely empty. It's just me talking to myself in COVID in a meetup. So first of all, thank you so much for joining. I hope your COVID experience hasn't been too rough. This is obviously a very new experience for me, doing a meetup like this without Wagner and Manu in the front row heckling me. But please do jump in with Q&A, or any of our moderators, please jump in if I miss the Q&A or anything like that. I'm looking at a different screen right now. Anyway, I'm really excited about this meetup. As Wagner correctly said, I pitched this in March. It didn't make the cut for Global Integration Bootcamp, so I did patterns of function integration patterns, which I really enjoyed as well. And I borrowed a couple of slides for this talk as well. But I'm kind of glad I didn't do it then, because I've learned so much about this topic since then, and I continue to learn. So Service Bus and high availability, two of my favorite things that I'm interested in. They're both part of the distributed computing field of computer science and engineering, I guess. And that's where I find myself drawn to more and more these days. Before I get started, as you know, I work for Microsoft, and the great thing about working for Microsoft is that we are allowed to talk about our products and services in public and express our own opinions about them. But the proviso is you must remember that these opinions are my own, particularly the slides that I'm going to talk about with data center architecture. I don't work for Azure Global, so there's lots of different organizations at Microsoft. Azure Global are the team that look after our global data center infrastructure. And what I'm going to tell you about how those data centers work, I've gleaned from working with those people and being a consumer of their infrastructure. I work for Azure Engineering, and Azure Engineering is an engineering team made up of engineers and PMs and all sorts of people who build the products and services that I'm sure you're using in Azure today. And the team I work on specifically is FastTrack for Azure. A little plug for FastTrack if you haven't heard of us. We're a bunch of engineers and program managers globally. There's more than 250 of us now who work with customers to help them to deploy their workloads into Azure. And our only job, the only metric that we're measured on, is that customers are successful and that they have a good experience. So what we do is we submit feedback to our product teams. We tell them when things aren't working that great. We also give them the positive feedback when that comes through as well, and we communicate back the other way as well. New features, how to configure things, all of that sort of thing. It's a cool job. I really love it. It's amazing to be based in Auckland and be able to work globally, and also just great to be able to share what I've learned with you today. Just a little bit more on my qualifications for this talk. I look after the app compute team globally for FastTrack. And what that means is I oversee the patterns and practices and guidance and training for the engineers who work in what's called our app compute category of services, which includes app services, logic apps, functions, service bus, event hubs, and event grid, of course, and API management. I'm sure I've forgotten one there. But yeah, this is, I'm working in this every day. Our engineers are absolutely going deep on this technology all the time. I'm also part of our architecture V team globally, where I get a chance to contribute to our patterns and practices, our docs, and make sure that we have a consistent approach to the way that we architect or give it architecture advice to customers. That's performing architectural reviews, helping people to design for high availability is a big part of what we do. So yeah, that's just gives you an insight into what I'm doing for Microsoft today. Anyway, enough of that. Let's get into the topic at hand, which is these services, Azure messaging services. I'm just going to talk about these three today. Service Bus, as you already know, is our reliable messaging broker. It's a message broker which is often used as a high-speed bus in service-oriented architectures. It's very extremely powerful. It's used a lot in enterprise integration. It's a server-side cursor, so it has very good reliability, reliable messaging, and some pretty strong guarantees around what happens, which is good. Event Hubs, as I'm sure you know, is our high throughput ingestion machine. It's there's another variant of it which is called IoT Hubs. It maintains a client-side cursor, which is how we manage to get, or how you can get such a high throughput through that service. Think of very large, high-scale ingestion services like Application Insights is built on Event Hubs. Xbox, so all the activity that's collected from Xbox controllers and devices goes through Event Hubs. I'm sure you're building Event Hub solutions as well. This is a very large-scale, high-throughput ingestion. And Event Grid is cloud-scale eventing. This is a very exciting, relatively new service, I guess, where you can create these event-driven architectures of the events that happen inside Azure and other clouds, but mostly in Azure. So, for example, you could say, well, this blob, someone's uploaded a blob. Let's trigger something else off. More on that in a minute. I'm going to assume, for the purposes of this talk, that you know quite a bit about Azure and that you know quite a bit about our Azure messaging service. This talk is really aimed at integration architects and engineers who are already working with these services. However, if you're not, that's fine. Please drop your questions into Q&A. We've got a very helpful panel who can jump in and answer those. And hopefully, and I've actually got a bit of time at the end to have Q&A as well. But we're going to go really deep on this talk, just warning. Yeah, we're going to get into some pretty funky stuff, certainly by the end, so that's cool. Anyway, let's start with the... Hey, what's that?
Exactly what you were looking for.
Exactly. Oh, that's good. That's good. So let's start with a couple of basics just to get our brains into messaging mode. Here's a slide from Global Integration Bootcamp, which I did on integration patterns for functions. This is the classic pipes and filters. In this pattern, you can see that an Azure Service Bus queue is the pipe in this pattern, and the function is the filter. And we're passing messages through our pipes and filters. Service Bus is excellent for that, for providing queues for that sort of pattern. Pub sub, very common. Most people will know and understand this topic quite well by now. By the way, there are links on the bottom of these slides. Hopefully they're clickable on your screen so you can jump straight into the docs and read a bit more about those. Here's pub sub with an Azure Service Bus topic. The topic is named comment created, and you can see that function on the left-hand side is generating comments. It's generating messages on that topic when a comment is created, and those two other functions are consuming them as subscribers. The publisher is not aware of the subscribers. It's decoupled from the subscriber. It's just basically emitting messages as soon as they are created. Those two subscribers are subscribing to that topic. We guarantee we will deliver those messages to each one of those subscribers, and then they can go away and do something that's interesting to them, such as building a dashboard or sending a notification, for example. This is classic service-oriented architecture, maybe fine-grained SOA if you like. This is event streaming. So as I mentioned before, when we think of event hubs, we think of tens of millions of devices, all sending analytics, activity, other data as fast as they can to a high ingestion endpoint. The way we do this at Microsoft is we connect these devices directly to the AMQP endpoint, which is event hubs or IoT hubs, and we're basically just firing messages as fast as we can. Not all these clients will stick around and wait for an ACK. That's how they get that throughput, and they're not really trying too hard to synchronize the cursor. We really are just trying to get messages through as quickly as we can. Stream analytics is then used to aggregate those events into something a bit more meaningful, where we can put it into a materialized view, say in Cosmos DB, where we can view that as a dashboard in Power BI. On the bottom row there is an example of, say, we might get Stream Analytics to aggregate and filter some of those events and then pass them into a data lake where we can run Databricks or another machine learning process over the top of them to get some meaningful insights on that activity. So super cool patterns there, which are powered by event hubs and IoT hubs. These are very simplistic examples just to get us into the mode. This talk is not about patterns, so I'm just trying to introduce some of these to get us into the zone. Event grid is, as I said before, a blob. We upload a blob into blob storage. That triggers an event in event grid. Event grid may then call a function which logs something into Cosmos DB, or it might trigger an automation event. So that automation event on the right-hand side and kick off some sort of automation process inside Azure. We can build very rich event-driven architectures using Event Grid. A couple of slides back, I had a link to comparing these slides, or I thought I did. So I'll just grab that for you now. Here it is. This is a really good page. If someone wouldn't mind dropping that link into the Q&A to choose between, how do you choose between those different services? So between Event Grid, Event Hubs, and Service Bus. Can you see that? No, you can't. Sorry. Stand by. Hopefully that's better. And yeah, choosing between the Azure messaging services, Event Grid, Event Hubs, and Service Bus. Really good article there that goes through the pros and cons of each. I would argue you don't really need to make a choice. All three of these should be in your architecture in some ways, but it's really important to understand when to use them and when to use something else. Right, so this talk is about availability, and before I bombard you with jargon, I just want to define a couple of terms, or redefine a couple of terms. The first one is availability. You'll often hear this referred to as high availability, or HA. However, most services, well, certainly in PaaS and in cloud, are highly available, so the high part is a little bit redundant, but it's closely related to uptime. So it's the availability is the ability of a system to be available to respond to requests. So we're talking about, is it available or is it unavailable? We typically measure these by an uptime as a percentage per month. So I'm sure you've seen things like this. 3 nines would be 99.9%. We would say that colloquially as 3 nines. 3.5 nines would be 99.95%, and 4 nines would be 99.99%. And there are degrees of availability. Some services, SKUs, and deployment configurations are more available than others. More on that coming soon. Recovery, I would like to redefine this term as well. We often talk about disaster recovery. However, these days, disaster, yeah, I mean, we've had a couple already this year. We probably need to redefine how we think about disasters. I just really want to simplify this term down to recovery, because those are the two important things to grasp from a high availability point of view or reliability point of view, is availability and recovery. So recovery is how quickly can a system recover from failure, and how much data would be lost in the event of a failure, which is a really challenging question. And we measure these commonly in two ways. First one is RTO, which is the recovery time objective. What's our objective for being able to recover a system if it fails for any reason? RPO is the recovery point objective. The challenging question for that is how much data are we prepared to lose? And while that may be a little bit of an uncomfortable question, if you're running a SQL Server cluster and you're backing up once a day, so you're doing incremental daily backups, your RPO is measured in hours, in fact 24 hours. So yeah, that's a good way to think about that. But typically, these we measure recovery RTOs and RPOs either in seconds or minutes or hours or days. Those are the orders of magnitude. So yeah, it's we would probably design quite differently for a system that needed an RTO of seconds versus a system that had an RTO of days, for example. Let's talk about high availability of these services in general. So there's really good news for you, and that is that Azure messaging services are already highly available and they are backed by a financial guarantee. So you don't need to configure anything or even architect in any special way to achieve this. This is not a button that you enable on the portal. This is, even in the most basic SKUs for these three products, the actual guaranteed uptime, financially guaranteed uptime for these services. So working from left to right, Service Bus has an SLA uptime of 99.9%, aka 3 nines, also known as 3 nines. That means you should plan for, but not expect, up to 44 minutes of downtime per month. However, we have to be a bit careful with that statement because we wouldn't expect all that downtime to come at once. That 44 minutes could be spread across the month if it actually even occurs at all. Event Hubs has a higher SLA. This is 99.95%. That means that you should plan for around 22 minutes of downtime per month. And Event Grid is a very good uptime SLA. Plan for 4 minutes of downtime per month. And I'll go in and dig into those SLAs on a later slide to show you exactly where that's written down and how you can incorporate that into your calculations. This is how Azure Service Bus infrastructure is architected in a single region. So it's important to know that a single Azure region is made up of multiple data centers. If you've heard any FUD otherwise, don't believe it. There's always been multiple data centers in every Azure region globally. And each data center, furthermore, there are multiple fault domains. So think of a fault domain as a corridor or a group of racks that have independent top of rack equipment, which means that they have independent power supplies and independent networking systems that ensure if there's a fault in one of those domains, it does not impact the other domains. Clustered services like Service Bus are able to maintain a quorum when there is a fault in one domain by basically striping their clusters across those other, across all three domains, for example. And we're talking about very large clusters. We're talking about hundreds of VMs and hosts just for hosting a Service Bus service, just for one multi-tenanted service. These things are massive. This is clustering at scale. So very 3 of these setups, and these get even more complicated and more, even more infrastructure is deployed in a zone, in a region that has availability zones, and I'm going to talk about those soon. Again, if there's any Q&A, please drop it into the Q&A chat and let me know if anything comes in. There's a question here from Bala. Usually SLAs in Azure are not applicable in DR scenarios. Is that correct for Service Bus? No. If you're referring to the financial guarantee, we absolutely guarantee financially that those services will remain up and running. So if there was a disaster, and I'll talk about this a lot more later on, then we would, you would be entitled to a financial compensation under the SLA agreement if it was deemed that there was a breach of that SLA, even in a disaster. It doesn't really make any difference. All of our regions and zones and data centers are built for disaster recovery scenarios. So a lot more on that coming later on in the talk. Good question. Oops, I keep pressing the wrong button. Sorry, team. How's that? Okay. If we look at, so we were just looking at this is Azure Service Bus infrastructure. If we put a layer of abstraction on that and just think of this now as an individual service, well, that's fine. But what if this service becomes available for any reason? For example, a few months ago, a service update was deployed that slowed down management operations on Service Bus in a few regions, and just a small subset of customers were impacted. That failure lasted for 3 hours. It was resolved by the engineering team rolling back the update. Some of you may have been impacted today by a short outage on Azure AD, similar story. You know, these are service failures that we should plan for, and we should be resilient to by following some of the suggestions that I'm going to give you later in this talk. These sort of things do happen from time to time, so it's important that we have a plan for it. And no amount of infrastructure can protect us from those things, so we do have to have a plan. Now, generally, when a service fails, there are two types of failure. Failures in Azure services are either transient or they're persistent. So a transient failure is usually less than a minute, typically just a few seconds, and this is the most common failure mode in Azure. Would be a transient failure caused by things like intermittent network connectivity, a load balancer doing a switcheroo and dropping all the TCP connections while it switches to another cluster, a host being detected to be unhealthy, and a VM being detected to be unhealthy and being taken out of a cluster, those sort of things, rolling update patches. These all cause very short, very intermittent, transient failures on servers, which last typically less than a second, but at most a few seconds. And the reason why I know this is because it's actually written in the details of the SLA. So let's go and have a look at that right now. I'm going to switch to my browser. Go and have a look at the SLA for Service Bus, since that's what this talk is about. And we'll see here, now, who loves reading SLAs? I mean, I know I do. That's a joke. No one loves reading SLAs, but this is your job. If you are a solution architect or an integration architect, then you need to understand these SLAs and what you've signed up for, especially with a service like Service Bus if it's being used in a mission critical or business critical situation. And there's two important pieces in this SLA. One is that we guarantee that at least 99.9% of the time, that's 3 nines, a properly configured application will be able to send or receive messages or perform other operations on a deployed queue or topic. So far good. So far so good. We've got a 3 nines uptime. Now, the devil, as always, is in the details. So let's go right down here to what is the definition of downtime. And this is really interesting. Downtime, a minute is considered unavailable for a given queue or topic if all continuous attempts to send or receive messages or perform other operations on the queue or topic throughout the minute return an error code or do not result in a success code. Now, what we're saying there is the team are giving you an indication of the failure mode for this service. They're saying we expect these failures to be transient, therefore we want you to retry, and not only that, we expect you to retry for up to a minute. So that's the big lesson here. For transient failures, we need to be resilient to transient failures. We can't claim them under SLA. These are actually expected as a failure mode by the team. You should retry for up to a minute. Now, fortunately, we build retry support into the Service Bus SDK, so the .NET client, if you're using it, has this capability built in, but you need to know how this thing works. So you should go and look at the retry. Let me find it for you. Here it is. We've got very, very good detail around this in the in docs. So this is the retry mechanism for the Service Bus client library. It tells you what its default policy is, what the default values are, how often it's retrying. It's really important to understand what's going on under the hood here, and just making sure that you are actually retrying and protecting and being resilient to transient failure. More in that document. It's a really interesting read. What about persistent failures? So when the service stops responding to a request for more than 1 minute, there are 3 options basically. Option 1 is really easy. It's just wait. Okay, it's actually a pretty good option. If your RTO is measured in hours, then this is actually the simplest and cheapest strategy, is just wait for Azure to fix it. The AAD issue today was resolved in hours. The Service Bus issue I mentioned a few months ago was also resolved in hours. These are reliable systems. The Azure Engineering getting really good at fixing these in a hurry. We don't want persistent failure. It's certainly not our normal mode of operation, but we hope to be able to resolve these pretty quickly. So yeah, typically Azure service failures are resolved in minutes or hours, and if your RTO is measured in hours, then you could just wait for us to fix it. That's option number 1. Option number 2, and I would actually do this as well, is to have a runbook. So what is a runbook? It's a, well, in the olden times, it was a Word document that sat on the network drive where all the operators knew where to find it. And in the event of an issue, we would all go and open it up and remind ourselves what to do. This is a high pressure situation. It's a survey on prod. Customers are probably ringing up. The CEO is probably on his way downstairs to tell us off. We need to have a plan. And this is something that I highly recommend. I'm constantly, I think it's really important for teams to have a runbook, and I'm going to show you a simple example of what one could look like. So a runbook, this is a runbook that I've written as an example for a service bus persistent failure. The failure mode is that service bus has not been responded to repeated retries for more than a minute. So the very first thing we do after we've woken up Bob is to try to redeploy the service bus with a new namespace in the same region. So our strategy here is maybe this is just an issue with this particular tenant or super tenant or this particular cluster. Maybe we can get lucky and redeploy this on a new namespace. We've even written a PowerShell script so that we can do this in a real hurry. It's called deploy-sb, and we're passing in a new namespace name. Notice that, mysasap2-aue-bus. AUE stands for Australia East, and we're asking to deploy this into Australia East. Now, what the script will do is it'll create the namespace. It'll also create all the queues and all the topics and the policies and everything else so that we don't have to muck around doing that manually. Our recovery time here is measured by how fast we can execute this script. Now, if that's successful, then we can do the next thing that we want to do, and that's fail over to this new namespace that we've just created. We do that by changing the connection string in the Azure configuration service that we've deployed to do this. So what this script is doing is it's setting the new primary to this new namespace. The region is Australia East, and this script is going and querying the service for its connection string, for its policies, its access policies, and then injecting them as configuration into Azure configuration service, which is dynamically updating the clients so that they can now reconnect to our new primary namespace. So this is a common technique. It's something that we would try in the current region. If that doesn't work, then let's try it in our secondary region. So as you know, every region has a pair. For Australia East, this is Australia Southeast. We're going to run that script again because our first strategy didn't work. We'll redeploy it into the secondary region. Notice that my naming reflects this. It's mysasap2-ASE-bus, and I'm deploying into Australia Southeast. ASE stands for Australia Southeast in this case. That will be successful because that region's good, and now we can fail over. We can point our new primary to that secondary service bus. It's deployed in Australia Southeast. Azure Configuration Service will automatically update all the clients which are running in Australia East. And you may say, well, hang on a minute. Those clients need to connect now from Australia East to Australia Southeast. Isn't that going to have an impact on latency? The answer is yes, it will. But now we were running in degraded mode. And the choice here for the business is, would you prefer to run in degraded mode where the latency for sending our messages is slightly lower while we go and resolve this issue in the primary region, or would you like us just to stop working altogether? And most businesses will say, well, we'll take degraded mode, thanks, and we'll just ride our way through this for a couple of hours until that issue is resolved. So that's just a really simple example of a runbook. We would continue to monitor until that primary recovers, and then we would run the failback runbook. Pretty cool. So I'm just going to check the Q&A. Anything else coming through? I like the idea. Does a different namespace guarantee some different machines load balancers behind the scenes? We don't know. That's a really good question and good points. That's why we're kind of trying in the primary region. But what we do know is that if the primary region is not responding to service bus management events, the secondary region definitely will. So we know if that fails, we can fall back to that secondary region. So thank you for that question.
Yeah, Dan, there was another question on, does 99.9% mean will be down every month?
Yeah, another good question. No, it doesn't. That gives you an order. It gives you an example of the magnitude of the amount of downtime that you should plan for, not expect. And that's a key difference. You should be planning for that amount of downtime, and it's really just to give you an indication, that order of magnitude. So there's a big difference between 3 nines and 4 nines, and really you just need a plan in place for for that level of downtime. A lot of these services, and Service Bus and Event Hubs are one of them, we're observing them actually performing to requests at greater than 5 nines, which is phenomenal. That's a very good uptime. So yeah, we don't want these services to be unavailable. We're measured on these numbers, by the way. So yeah, all of our engineering teams are really motivated to exceed those metrics if they can. Cool question. Right. However, if that's not enough, so we don't want to wait. The Runbook's not fast enough for us. We do have another option. And if you haven't heard of these, I wanted to introduce you to availability zones, which are now generally available in Australia East. And this is a feature that you can take advantage of now. So Service Bus, Event Hubs, and Event Grid are all zone redundant services, and you can enable zone redundancy when you create. Sorry about that. When you create them like this. So you tick that box if you're using the portal, or you set a property in your Terraform, or you set a property in your ARM, and now that service is zone redundant. And I'll show you what that means in a minute. Unfortunately, you have to, this only works when you create a namespace. So you can't upgrade a namespace to be zone redundant. You're going to need to migrate it by creating a new one and migrating over to it. If you need some help with that, let FastTrack know, we can help with that. But yeah, that's the story at the moment. And then what that unlocks is something like this. So remember I shared with you earlier a single region data center architecture where we're just relying on what's called availability sets or those fault domains. This is taking it up a level now. This is zone redundancy, which is provided by these availability zones. And this is Australia East right now. And by the way, this is GA for anyone who wants to log into the portal. If you go in, you'll see that it's there. We haven't announced it publicly, but I can assure you it's working and ready for you on all of our messaging services today. And this gives us hundreds of VMs again, hundreds of VMs and hosts. So this is a massive Service Bus cluster. I might have mentioned already that Event Hubs is hosted on Service Bus, and so is Event Grid. So Service Bus is the reason why I talk about Service Bus so much is because it's actually the service that those other two products are built on, Event Hubs and Event Grid. These are massive clusters, and when we deploy a zone redundant tenant for you, we're striping that across a cluster, which is a multi-tenanted cluster, which is striped across multiple zones, so multiple availability zones. What is an availability zone? Well, it's one or two or sometimes three in separate data zones that data centers that make up an availability zone. And as already described, inside those data centers are the fault domains and availability sets and whatnot. Each one of these zones has a 5 nines uptime from an infrastructure uptime point of view. So we can combine 2 times 5 nines. The mass for that is 1 over 5 nines multiplied by 1 over 5 nines gives you an incredibly high uptime. So the probability of multiple zones going down is very, very low. And when we stripe our cluster across multiple zones, we can maintain a quorum when one of those zones, if there is a failure in one of those zones, which is really powerful. And then I've drawn here just logically a zone redundant load balancer, which is now load balancing across these zones so that when you connect to it via the public IP that's deployed for this service, we're directing your traffic to whichever node in the cluster is handling your requests. Very cool. Huge investment in infrastructure. This is how the New Zealand North region will be deployed as well in a configuration like this. I love data center photos, so here is a couple to share with you now. I have no idea where this region is, when no one's saying, but this is a build of a data center for Microsoft. This is an Azure data center. Look at this infrastructure. That's a road. Those are cooling towers. There's multiple buildings. See those cranes there in the distance? Well, that's the next phase of development. You can see the size of the machines and the people working on this. We're talking about huge amounts of concrete, fiber, cabling, infrastructure. Microsoft spends a phenomenal amount of infrastructure every month, and it's investing in data centers and regions and availability zones like this. And inside, very clean, no humans here. These are completely automated systems where there's no one walking around. There's not a label on one of these racks with the name of your tenant on it. There's nothing like that. We are striping multi-tenanted services across hundreds or thousands of nodes, which are deployed into racks and corridors like this. Very secure, very clean, and highly automated environments. We don't have anything like this in New Zealand today, so we're very, very excited for the arrival of our New Zealand North region when it gets here, and that will have multiple availability zones that we can leverage. Now, despite this phenomenal amount of infrastructure and investment, we still get asked from time to time, well, you know, what happens if a meteor takes out the data center? And that's quite an annoying question. As an architect, as an engineer, we need to rethink our definition of disaster, because if these three availability zones were, for example, located in a triangle around the greater Sydney area, then that would need to be an extremely large meteor. And after we finish high-fiving each other for our robust DR strategy that helped us to avoid, to stay resilient through a meteor strike, we can begin mourning the 5 million souls who perished under the impact of that meteor strike. And I make this very terrible point to ask you to challenge these movie plot scenarios in your business. Encourage your business to carefully evaluate the risks when choosing a disaster recovery strategy. And just to really think carefully about what are the actual disasters that could happen. You know, the disasters that happen in data centers these days are, you know, lightning strikes, an HVAC that disables the cooling system. We have to shut down all the systems in that availability zone to stop the motherboards from melting. And I mean that literally. So that would be an example of a zone failure. And when we do that, what we want is that the entire region continues to function and those zone redundant services continue to function through that disaster. But having said all of that, some customers still just want to protect themselves from an all of region failure. And that's fair enough. And I help customers to design architecture like this. So let's run through that scenario. The scenario is Zone 2 fails, Zone 1 gets taken out by Godzilla, and King Kong rips out the fiber to Zone 3, and now we have a regional failure. So how do we protect ourselves from this particular scenario? Well, again, remember your training. In the event of such a disaster, we've got two options immediately. One is wait. Let's see if we can recover the region. Let's adjust our RTO for a regional failure. Maybe we can be a little bit more relaxed about that particular scenario due to the magnitude of the event. Option 2 is have a runbook. So again, that's that runbook example that I gave you. Also works for a multi-region architecture scenario, and we can actually redeploy into that second region and keep on tracking. But if all of that is still not enough, then we have another option, and that is a multi-region architecture based on region pairs. That's the third box here. And for this, we really need to stand around a whiteboard and write some code and really practice architecture. So we're going to get into this section of the talk now, where we start getting into these high availability cloud solution architecture patterns. You ready? All right, here we go. Should we pause for questions? Have there been any more come through, guys?
Yeah, Dan, there's been a bunch. We're answering them, but yeah, nice. there's a good one up here around service bus with DR. Active that might take a little bit more discussion, but
that's coming up. Yeah,
yeah, I thought you would.
I've got a whole pattern on that, so we'll jump into that.
Yeah, we might have to go revisit some of these because I'm sure you've got some great context and info to share in them.
We'll recap at the end, no problem.
Thanks, mate.
Sweet. So if your RTO for a regional outage is measured in minutes or less, your recovery time by the business, and it's the business that should be deciding these metrics, by the way, not the architects or engineers. If that's measured in minutes or less, then you probably need a multi-region architecture. And as a starting point, I've built just out one side of this in Australia East. I've got API Manager there. That's that top blue box. It's talking to a couple of functions, and one of those functions is talking to a service bus. That service bus is named MySASApp-AUE-bus, and I've deployed it in a zone redundant configuration. So far so good. That's one region sorted. the multi-region design is simply deploying every service twice, so once in each region. Now we need a load balancer to load balance across them, and my general recommendation is to run on an active-passive configuration for messaging, and that means that in normal mode, the primary region has priority. We're using priority-based routing, so that means that all requests will be sent to the primary region, while the secondary region sits there and waits for us to fail over. Now, this goes against some of our marketing, which highlights that you can use performance-based routing in products like Traffic Manager and use active-active scenarios. However, active-active and performance-based routing never really, or it very rarely makes sense in enterprise messaging. Active-passive acknowledges that there is probably going to be an affinity for one region and embraces it as part of the design. So if you're going to choose a primary region, choose Australia East, because until New Zealand North comes along, it's the most capable region in our neck of the woods. It's a so-called hero region. Now, what about Geo-DR? So you may be asking, well, hang on a minute, isn't there this feature called Geo-DR? Well, yes, there is a feature in Service Bus called Azure Service Bus Geo Disaster Recovery, and this feature allows you to pair namespaces like this. So the purple arrow is pairing two namespaces together. They're now associated with each other. This also works for event hubs, by the way, and it also adds an alias. So an alias is an endpoint that you can point those functions to and connect them to directly. The alias will essentially just redirect requests to the primary namespace, and currently in this drawing that primary namespace is mysasapp-aue-bus, but look at the alias name. It has no indication of the region because it's a cross-region resource. It's called mysasapp-bus. Now, there's a bit of a gotcha with Service Bus Geo-DR because messages are not replicated. Now, at first glance, that probably seems like a pretty crazy feature to call Geo-DR if you're not actually replicating any of the messages between those buses. But yeah, we actually don't. We're only replicating the queues, topics, filters, actions, and policies, so the so-called entities in those namespaces from one side to another. The messages are not replicated. So you can't rely on Service Bus Active Geo-DR for message replication. We need to do something else. Now, to explain what to do in this particular scenario with the Geo-DR feature activated, then what I'm going to do is I'm going to walk through that process of failing forward to a secondary namespace. This takes a bit of explaining, so bear with me. What essentially we're doing is we're abandoning the ship. So when there is a failure on the primary namespace, we, the customer, we must wait a few minutes before initiating a failover, typically up until almost our RTO. So what I mean by that is if our RTO is 30 minutes, we'd probably wait until the 20-minute mark before we push the failover button. The failover for Service Bus can only be initiated by you, the customer. Azure won't do this for you. And when you do that, what we're doing, so here's that Service Bus, it's gone bad. Now we've decided to failover. Watch that green arrow. It's switched from one side to the other, and now those requests to mysasapp-bus are being redirected to that secondary namespace. And also those namespaces have been unpaired. Notice that that purple arrow has just disappeared. Now, the nice thing about this is you don't need to update your clients. Your clients will keep on trucking. They're now just talking to the secondary namespace. So next you would fail over the load balancer by changing that top green arrow to your secondary region, and now your secondary region is active. And now our clients that are connecting to APIM, they can retry their operations in the secondary region. So yeah, that's a lot from a fail forward scenario. We're now operating in our secondary region and waiting for that primary region to recover. So hold on tight. We're going to talk about failing forward back to the primary region. You with me? All right, here we go. So when Service Buses starts responding to management commands in the primary region again, we create a new primary namespace with a new name, and we pair it again to the secondary. So notice that's original namespace that went down is still there, hasn't gone anywhere, but we've had to create a new one. And the reason why is we can only pair an empty namespace. So that's the rub. When we're ready to fail forward again to the new namespace, well, we redirect that alias back to our primary region, which is now pointing at this new namespace we've created called mysasapp-2-aue-bus. And at the same time, we fail the load balancer back to the primary region again. All right, So that's a biggie. We haven't actually gone back to that original namespace. So once you've failed over Service Bus, the primary namespace, it can't be paired again. It's basically just sitting there idle. Only a new empty namespace can be paired. But what it's sitting there and enabling us to do is to get the messages back. And I have to give an apology at this point to Wagner and Manu, who proved me wrong so many times, and they were right about this as well. And that is that namespace is still available for you to extract those messages from if you need to. But now you've got to make a business decision. Is that something you actually want to do? You've probably already reprocessed those messages on that secondary bus, and that's probably no longer required. But there's definitely a business decision to be made about what you do with those messages that are still sitting on that bus, that's on that namespace that's been recovered. So what you could do is you could delete them all, or you could reprocess them, or you could process them on a case-by-case basis. That depends on your design and your business decisions. And eventually, you can delete that original namespace as it no longer can be used. Now, if all of that is a bit concerning to you and you're really worried about abandoning a namespace because you're worried about losing messages, then frankly, you're probably taking too much of a dependency on Azure messaging services as a persistent storage service. Don't do that. That would be considered to be an anti-pattern. While we guarantee that you'll never lose a message, and we haven't yet, the fact that messages can't have a TTL of more than 14 days in Service Bus and Event Hubs is a pretty good indicator that we don't intend it to be used as durable storage like we would Cosmos DB, for example. So use it as a bus, as a message bus for sending messages. I'm not saying the messages are ephemeral, they're not, but yeah, don't rely on too much. You should be able to replay and abandon a namespace if you really have to, and you should have runbooks in place for these crazy scenarios that we have to get into when we really get into high availability. Super interesting though, right? Right, I'm going to get into these active replication patterns. Do you want me to pause there, DSR, or are we good?
We've got a number of questions relating to DR. I think there's a good one. Really, this is a just good one. How many messages can Service Bus handle per second, and how does it scale? I'm sure it's an easy one for you to jump on.
Yep, absolutely. So use Service Bus Premium. You deploy messaging units. Every one of those messaging units, I'm not sure on the number, but it's something like 10,000 or 100,000 RPS. These are very high throughput systems. So if you need more throughput, then you up the messaging units. If heaven forbid you were to run out of that, then we would stripe your workload across multiple namespaces. Was it just the throughput they were interested in, the message sizes as well?
Just the throughput. But what I'll do is I'll dig out the docs for the Service Bus quotas and limits and post that. And then if they have a look through and just let us know if there's any other questions that you want Dan to or dig more detail into that, we can jump in on that. There's another question: can clients still use the alias to get the messages with having the apps to fail over, except the namespace is failed over?
Yeah, good question. So you can't use the alias to get the messages back from the namespace that was failed, that was abandoned, but you can connect directly to it by its name to extract those messages out. To pull those messages.
And that's because the namespace is now being used by the new pair system.
That's right.
Right. So the from a business continuity point of view, or a system continuity point of view, in theory your clients didn't stop apart from that initial outage, because it continues going through their same connection, but now to the secondary node. And when you added the new node there, now you have kind of protected again, and that's why we cannot use the alias to go to that one that you abandoned.
Yeah, that's correct. What was I going to say about that? Yeah, your recovery time there is how fast can you fail over. That would still be measured in minutes. And I'm going to show you a pattern right now, which if minutes is too long to wait, then we can get that down to seconds or close to zero. We need to go a little bit further into software engineering to fix that.
And then it is also an application level change that would require you to go and read back from those queues, the deleted queue or the no longer used queue.
Yeah, I would describe that as an ops process. Yep. You're probably hand picking through messages, to be honest, and choosing which ones you're going to keep and which ones you're going to throw away. Unless you've got a really good automated mitigation process, then yeah, that's probably what you're doing. You've got to remember this is a disaster event. This isn't something that we would do every day. There's diminishing returns in writing automated mitigations for those types of recovery processes. We definitely would do that inside Azure because we're working at that scale, but you need to weigh up how much engineering effort you're going to put into those mitigation strategies versus, hey, let's just do a good old-fashioned look through the messages and see what we need to do. If you're practicing item potency, this is a lot easier. You can just run all of those messages through again, and item potency is going to, or deduplication is going to sort it out. You can connect directly to a service bus that has been paired via its name. Yep, so that's a good question too.
Awesome.
Awesome. All right, I'll carry on. So hopefully you can see my slides again. We're into active replication. So we're only three patterns away from ending this. And we're really getting into the thin edge of the wedge of high availability now. So active replication, really interesting pattern. It's described in that link that's on the bottom of the slide. You can click on that now if you want to read more about it. This is the sledgehammer approach to high availability in Service Bus. Basically, we send every message twice to two queues or two topics. You'll notice that both the messages in this diagram, which are drawn in purple, have the same ID. We're sending a duplicate of the message to the secondary bus. What does that mean? It means our functions have to receive from both of those buses. So what we do is we send to both and we receive from both. On the receive end, the first one wins and we discard the duplicate. That implies we need to be able to dedupe within the function. So we need a record of the message IDs, and we need to be able to understand when we've received a duplicate and simply discard it. So yeah, interesting pattern, quite simple from an implementation point of view, but I would describe this as the sledgehammer approach. It'll work for sure, but yeah, it's pretty brute force. The next pattern is called passive replication. This is really interesting. This is when it's a similar pattern. What we do is the function will try on the primary namespace, and if that's down, then it will retry. So it'll probably retry, 3 or 4 times on the primary namespace. Then it will circuit break and fail over to the secondary. So what it'll do is it'll retry onto the second. This is also known as the intelligent client pattern. And then we've got a message on that bus with an ID of ABC123, but there's no duplicate. It's only been sent once. Again, our functions must be reading or receiving from both namespaces. So that means that they're receiving or being triggered from both namespaces. And we do actually need deduplication here just for a very short period of time because there are edge cases here when a function could receive a duplicate of the message. It's very rare, but if you want to protect yourself from that, either practice item potency or have a deduplication strategy within the domain of the function. And
if order is important, then?
If order is important, you've got a couple of options. Sessions you can use, although use them very carefully and understand how they work. But otherwise, yeah, you may get out of order messages and your system should be able to cope with that. Have you got any other suggestions, Craig?
No, sorry, just for consideration, if we do need ordered processing, you need to, again, build, right? You have to think about that and actually build it in.
Yeah, absolutely. Yeah, sessions are really good. It's a feature I haven't mentioned, actually. There's a session feature in Service Bus, but it's one of those things you just don't turn it on for everything. Use it wisely. Only use it where you really need it. If you need ordered messages, just restrict it for a very, very short or the smallest part of your pipeline that you can, because there is a cost and some unintended consequences with using Service Bus sessions. We could probably do a whole nother talk on that, but I won't go into it right now. Nice. Okay, last one is the message pump. So this is a Clemens Vasta pattern. It's really cool. He's published his repo now. There's a link there to it. Basically, it involves deploying a pump, which is a function, and that pump is pumping messages from one namespace to another. We're essentially doing geo-replication of messages from one bus to another. So as soon as a message is created on that namespace in Australia East, it's being picked up by that pump, which is a function, and being replicated into the secondary namespace bus, which is deployed into Australia Southeast. Now, the really interesting thing about this is you can see that one is a duplicate of the other. So we've got an ID ABC123 on both of those messages. That's the message ID. But on the message that's in that secondary bus, we've set two more user properties. One is replicated equals true, and the other is source equals AUE. These are arbitrary properties. You can set whatever you want for user properties. This is an example, but these properties are being set by the filter action. So another amazing feature of Service Bus, again, we can do a whole talk on this, is filters and actions. So what a filter is I can set that pump, I can put a correlation filter on that pump to say, I only want to subscribe to messages where the replicated user property is empty, it's null, hasn't been set. Only give me those messages. And then on the way through, as I subscribe to them, I want replicated to be set to true, and I want the source to be set to AUE. So let me show you the code for that. This is code that you could deploy into an ARM template, although I haven't tested it, so you might have to adjust it. There is a smart quote in there just to trip us up, but this is a filter type of correlation filter. You can see that what we're saying here is I want to subscribe to, this is a subscription fragment of an ARM template, and I want to subscribe to any messages where the replicated property has not been set, where it's null or it's empty. And the action I want to set the replicated user property equals true, and I want to set the source equals AUE. Now, if you think about it, that's incredibly powerful. That allows us to build very rich topologies inside Service Bus without writing too much code, where we can start doing these crazy replication patterns, back and forwards, or we can start redirecting messages across different topics. All sorts of stuff like that. And there's a couple of good examples in those links there. So one of them is topic filters, and the other one is this CV Topo repo from Clemens, which will really give you a very detailed and quite complicated example of this. So this is, I guess, at the super high availability end of the scale. We want geo-replication of all of our messages across 2 regions, and there is a really good example of this in Event Grid. So Event Grid actually already does this for you. It was already replicating messages events across regions, and already replicating the topics and subscriptions across regions for you today. That feature is called Geo-DR. You should understand how that works in Event Grid, but in the event of a failure of a region, we've already replicated the topics and the subscriptions from one region to another, and the events will show up within minutes. So the RTO on that, the outside is 5 minutes. So we know within 5 minutes, all those events are going to show up in the other region as well. And you can subscribe on Event Grid from one region to another, which is really cool. I didn't realize you could do that. But you can just subscribe from Australia Southeast to a storage event that happens in Australia East, for example. So yeah, you can get some super cool event-driven topologies using the Geo-DR feature in Event Grid. Sweet. Before I go, I'm going to give a shout out for the Microsoft Azure well-architected framework. The reliability pillar contains a lot of what we've been talking about from an availability point of view. So availability and recovery, 2 big themes of that reliability pillar. There's a really good self-assessment that you can perform yourself or with your customers. Highly recommended. It'll ask you a whole bunch of really awkward questions about reliability. And if you don't answer them right, it'll send you to the appropriate document in the well-architected framework, which is quite cool. Also, Microsoft Learn, I cannot recommend this highly enough. The courses in Microsoft Learn, especially for well-architected framework, are really good. They're really well written and very comprehensive. So check those out as well. So in summary, we have covered a bunch in an hour. We started with Azure Messaging Services and acknowledged that these are platform services, and they're already actually highly available with a financially backed SLA, and that's probably good enough for a lot of customers. We've also discussed that most failures in the cloud are transient, and we should ensure our client is resilient to that. We should use the retry pattern, the circuit breaker, and failover patterns. Those are really good patterns for resiliency, and there's plenty more in the Azure Architecture Center. We should write runbooks. It's an oldie but a goodie. Runbooks will save your life time and time again, and practice failure mode analysis. We should understand the failure modes of the services that we're consuming from all vendors. We should enable zone redundant configuration in Australia East. That's something you can do right away, and you get great value from that immediately. And also understand Geo-DR if you're using it and how it works. Also Geo-DR and Event Grid can be very powerful and very useful. And if you need to, then build multi-region architectures for advanced availability requirements. As you can see, we can get very close to zero RTO and zero RPO with the right amount of architectural design and software engineering. Yeah, you'd be amazed at what you can do with those services. So that concludes my talk. Thank you very much for sticking around to the end. I hope that there's been some useful information in there for you. There's a bunch of links in my repo. Here's a link to it here. I also published the slides there, and if I get any feedback, I'll add more information there as well. So feel free to let me know. So yeah, thank you very much for having me, everyone. I really enjoyed prepping for this talk and really enjoyed delivering it. So thanks again.
Thank you, Dan. And we still have some questions here if you wanted to take them.
Go for it.
Cool. So the first one is this from Anonymous. If I understand correctly, SB guarantees at least, or Service Bus guarantees at least once delivery, but not only once delivery. So what is the pattern that we should be using, or that you recommend, or service, if there is any service in Azure that you could use out of the box to the duplication of those messages?
Yeah, so in my opinion, and I'll be interested in your opinion on this, Wagner, Service Bus guarantees delivery of the message once.
Yeah, at least once, right? Because of the if you're using the pick lock, I receive the message, then I process, but I fail to commit it back.
That's right.
And then I should be able to pick it up again. What I answer on that is that usually you should first aim for a hypothesis. That means that if you receive the message twice, you're going to end up with the same result, and that's what you should be like the gold standard on the client. Or you should have some kind of validation / deduplication service. But both of those are client responsibilities, and that's why you're talking about an intelligent client in this case.
Yeah, I mean, I would go further than that and say a well-engineered, functions with Service Bus solution, we can guarantee that message will be delivered once and only once to a function. You just have to be really careful about how you engineer it. But there's even those edge cases now are getting narrower and narrower. I find that we can actually enforce that single message guarantee. As long as we configure a few things. So one is, making sure that we configure the subscribers properly. We understand the competing consumers model. We may have to resort to running a function as a singleton, for example. That's not always appropriate. Then, as with everything, there's always pros and cons and trade-offs there. Mm-hmm. But if you really want single message delivery, I'm pretty confident we can give you that.
Okay. The next question on that one, it was asking if this pattern was across both topics and queues, and I was kind of in doubt if I was talking about the last one, message pump, yep, or about all of them. Would all of those patterns be applied to both queues and topics?
Let me think. Message pump, yes.
Mm-hmm.
No. Message pump, no. Sorry. Message pump, no, because you need subscribers. So subscriptions are only on topics. So you would need, is that right? I got that right?
Yeah, so the message pump would only work if you one of the subscribers from the topic was a topic on the other side. So you receive a message, you pump it to the other side with doing some change on that subscription, and then that distributes to the other subscribers as well. But then it's starting to become more and more complicated. Right, so it seems to fit really well to queue, where
really?
that we're just doing like one-to-one for each one of the queues. I have one on the side and the one on the other one.
Yeah,
you could do it, but it just becomes more complicated, I think.
Sure, yeah. Look, I don't know. I haven't built out Clemens's example, but yeah, go and have a look at that. He's got source code in that for that, and just check it out for yourself. I'm not too sure on that one, sorry, but my assumption would have been you needed a subscription if you wanted to use the filters part. That I just.
Mm-hmm. What do you think, Craig?
Yeah, the similar thing. on the same thing. You need a subscription in order to actually pump them across, right? So in order for the function to pull out, you're not pulling directly off the raw topic. Off the raw bus. So you need something
to use the correlation tables, right? I mean, if you're just going from queue to queue, no problems, and you don't really care. A pump will work fine there. You don't actually need the SQL filter and actions to do that. That's quite right.
Yeah, I'm just kind of making sure that in the back of my mind, when you pump it across to the second bus, I'm wondering if there's anything that will then trip up the existing filters for all your topics that might land on the other side as well. Yeah,
well, I mean, I'm not sure exactly how that would work.
Yeah, it depends on what you've got on that side.
So that one is a well architected maybe.
Yeah.
Just let me see. Shika was saying that it's like a kind of more heavy-handed as it requires multiple service bus artifacts. But what about using auto forward to other queues and topics?
Yeah, auto forward's really cool, but remember, if you auto forward, you can't receive off that queue and topic. So essentially, you're just redirecting to another queue or topic, and those are really cool for going in and fixing up problems or changing topologies on the fly. But don't imply from that you could receive off the queue or topic that you've forwarded, because you can't.
So you kind of trying to recreate the idea of topic subscriptions using just queues when you're doing the out forward, right?
Yeah, exactly.
Yeah. And what else? Well, then after that, I have like a whole raft of the thank you, Dan. Right?
Oh, nice.
Great talk, Dan. Could request that you share these slides. Amazing presentation, Dan. Thank you. And that's I would say that as well. And one last question here. We can enable the duplicate checks on service bus queues and topics, right?
Yes, that's right. As long as you are confident that your message ID is unique within your domain. Mm-hmm. So
the trick on that one is that actually you're talking about one queue or one topic that someone still needs to pick up the data from there, not between queues and topics across regions. That's what we're trying to do.
That's right. Yeah. If you're doing that, you need to dedupe yourself. Some people use Cosmos DB for that, but honestly, unless you're getting to super high reliability, I would just store a dictionary in RAM or a concurrent stack or something like that, and I'd hold the last 100 messages, or I'd hold them for an hour or something like that. It's a pretty good use of RAM on your function, as it's just a simple dedupe store. Again, all of these things depends on what is your trade-off between the risk of having a duplicate message and the cost that you want to put into engineering this solution, and that's an important discussion for the business. There are some systems where we never want to deliver the same message twice, although most people would cite payments, but even in payments, we roll back messages all the time in payments, so it's not always that cut and dry. But yeah, I'm sure there are scenarios, and I'm sure you've got one there where you need to be able to just absolutely guarantee that message is delivered once, and if you need that, then sure, architect around it, but only do it if you really need it.
Cool. And then I think Anonymous was just updating here that he meant exactly once delivery, so yes. That's what we're discussing, so it should be fine.
Yeah, I mean, we can take that offline, but I'm pretty confident that we can get you exactly once delivery semantics. The trick there is to use the retry semantics that are built into Service Bus, because what we need to cater for in those exactly once topologies is your point, Wagner, what if something goes wrong? So, we need to be able to retry at the function level, but Message Bus has really good semantics for retry and for circuit breaker. Don't forget, we've got the dead letter queue. The dead letter queue is really powerful for that stuff. If we're not able to successfully deliver that message, or if we detect that there's a conflict and we're unable to recover from it or compensate for it, then let's use that dead letter queue. That could be another automated process, or it could be a manual process. And let's not discount manual processes like runbooks, service desks, and operators who go through and fix up this stuff all the time. Anyone who's worked on BizTalk long enough has spent plenty of time in what's that thing called, the secure store browser or whatever it is, fixing up those sorts of problems. So yeah, I don't think that those sort of operational modes go away at this level of scale.
And you have really got a point in there with Service Bus. You have the retry counts right?
Yeah.
You have the dead letter queue, so there is a whole lot of things already on the fabric of Service Bus that help us to know if the message has been executed, at least the queued ones.
Yeah, I'm promoting that more and more now. I've realized that those semantics are actually retry patterns. So the number of retries on a service bus is retry pattern. That the failure count is circuit breaker, and now we've got a dead letter queue for failover. So those are really powerful semantics that we don't actually put into a function anymore. We would have written Poly to do that. But Poly has problems because you don't always want to retry an operation, right? That can actually be that can actually cause more problems. But if we want to just make sure that we're protecting from the failure of a client from consuming a message, we already have excellent semantics. Both in the input triggers for Service Bus have improved out of sight over the last few years. Event Hubs is getting there, but it's still a bit flaky. But Service Bus, yeah, excellent retry semantics on the input trigger that we can then leverage to really make sure that system is reliable.
Awesome. Well, I think that's it. Alessandro is saying that was like a level 400 Ignite quality mate.
Good.
So,
oh, really?
Yes.
Awesome.
And I have to agree, it was really, really good.
Yeah. Oh, nice. Oh, thank you so much. That's amazing compliment coming from you blokes. So I really appreciate it.
Thank you.
And great number of questions came through. I think there's still more. They're still coming. So I'm sure you could be here all night, Dan, if you feel like it.
Yeah. So with that, we're going to close for now because it's already 6:45. But what I can do is I'm going to have the whole live Q&A and send it to you. So if there is any other questions, you might publish them, or we can publish that on the Meetup as general questions later.
Yeah, great. Absolutely.
So some of them are coming from anonymous people, some from named people, so you can reply directly to them, or just like collate the things and put it here on the Meetup as comments, so everyone can see that one later on. Cool.
Very cool.
So with that, thank you everyone for the a very good session tonight. Really good attendance. We have a peak of 45, I think.
Nice.
Right.
That's great.
Yeah, which is kind of for us is kind of a record. And even now we still have 26 on the line, right after we finish everything, and it's just having the discussion. So thank you everyone, and see you next month, hopefully. Bye.
Thanks, Dan. Cheers.
Thanks, guys.
Cheers. Thanks, everyone.
Bye-bye.